Well, today we're going to continue our discussion of the non-model. Sort of do the reverse of what we did in the previous lesson. So in the previous lesson, we talked about the normal model and how almost all of the data points in a normally distributed data set will fall within three standard deviations above or below the mean. And we talked about this 68, 95, 99 point. I wrote 5. Now I'm just realizing that's a 7. So apologies. Hopefully you noticed that in the first lesson. That's just a typo. So almost 100% of our data points fall within 3 standard deviations of our mean, which is right there in the middle. And then we standardize this using z-scores. This is z equals 0, z equals 1, z equals -1, so on and so forth. 1 standard deviation above and below, 2 standard deviations above and below the mean, 3 standard deviations above and below the mean. The area under the curve represents the proportion or the percentage or the probability. Those are my data points that fall within a certain range. And so if we actually know the percentage underneath the curve, we can actually take that percentage and find a data value. So for example, we had this example where we were measuring fuel economy for these vehicles measured by the EPA, and we knew that it was a normal model, and here's our notation, a normal model with a mean of 24.8 miles per gallon and a standard deviation of 6.2 miles per gallon. That's what this notation tells us. And so we could draw that. And again, my normal curves are terrible, but a sketch is a sketch and it's helpful. There's our center around our mean. And so we'll ask this time, we want to know what vehicle, what miles per gallon, what fuel economy would this vehicle have if it represented the 15th percentile of our data set. And so 15% of my area under my curve is somewhere over here. Again, we don't need to be exact. This is just a sketch. I'm looking for this small tail that represents 15% of my area. And this time what I want to know is what data point is right there. In the previous lesson, we were given the mean and the standard deviation, and we're given the data point that we were interested in, and we were trying to find, hey, what percent of area is there? And so now we're going in the opposite direction. And so I'm going to go to my distribution list. I'm going to hit second bars. We have been using this normal CD method. We're doing the opposite. One might say we're doing the inverse of the normal practice we did before. So I would go down to number 3, inverse normal. Here we can tell the area under the curve that we want to know. And it's my understanding that on your calculator, you can tell it to if you want it from the left tail, the right tail, or the center. I have to tell it what is the area to the left of the data point I'm looking for. So that is 15% for us, so 0.15. And we're going to put it in decimal form. I need to tell it what my mean is. And I need to tell it what my standard deviation is. And it's going to tell me that if I do have this distribution, this normal distribution of values where the mean is 24.8 and the standard deviation is 6.2, that 15% of the data points will be to the left of this value of 18.37 miles per gallon, and I'll do 2 decimal places. So here we've taken a percentage and found a data point, and we'll give it the appropriate units based on the units we have in our scenario. So again, second bars, inverse normal. Here I want to find the 98th percentile. The 98th percentile is going to start somewhere over here to the right and then cover this area to the left. So we're looking for, hey, what miles per gallon puts 98% of our data points to the left of it? So I'm going to tell it that my area is 0.98. Keep my mean and standard deviation the same. And a vehicle with 37.53 miles per gallon would have 98% of the data points below it. So a very unusual fuel economy. So almost all of the data points, almost all of the vehicles will have a fuel economy that's less than 37.53. We can do the same thing when it came to our steers. Again, we have these steers that were distributed normally. That means they are unimodal, symmetric. We have a mean of 1,152 pounds with a standard deviation of 84. And again, we could draw that, sketch it. That one's a little better than last time. You don't have to do the standard deviations above and below every time if you don't want to. It's good to know how to do that though. Here we want to know what represents the 45th percentile. So the middle is the 50th percentile. So 45th is somewhere to the left here. We're looking for this area, or we have this area. We are looking for the weight of a steer that has 45% of the rest of the steer, the weight below it. So again, second VARS, inverse normal. I'm going to tell it my area to the left. Tell it my mean, my standard deviation, and it's going to tell me that 45% of the steer will weigh less than 1,141.44 pounds. Same idea with the 75th percentile. Which actually you might know also as quartile 3, because there's 25% of the data points above it and 75% of the data points below it. So quartile 1 would be the 25th percentile. And actually, if we wanted to find the IQR of this distribution, we could find the 75th percentile, the 25th percentile, and we could subtract them to find the IQR. But for now, let's just find the value that cuts off 75% of our data to the left. So again, second VARS, inverse normal. All we need to change is this to 75. And the weight of that steer would be 1,208.66 pounds. So as ever, if you have questions about this before you move on trying it yourself, please do ask. Here we have our scenario on IQ. Try to find the IQ score that represents these 3 different percentiles. If you need help looking through these or using the calculator, please do ask for help. Take your time on them and good luck.